Hello, my friends. Thank you very much for subscribing to our channel. Yesterday we discussed a topic regarding the carpool fare sharing. 3 persons take one taxi to go home. And there are 2 strategies of sharing the fare, that both sound very reasonable. One is to share it on a pro rata basis. And the 3 persons pay $10, $15 and $18 respectively. The other is to share it by splitting the fare of the journey where they have in common. And the 3 persons pay $9, $14 and $20. While both strategies sound reasonable, they produce completely different results. In this example, with the second strategy, the person with the longest journey would have to pay the fare a bit more than that with the first strategy. So the following question is this always the case? We can simplify the problem a little bit. Now we only consider 2 persons carpooling one taxi. The first person's journey is X kilometers. The second person's journey is Y kilometers. Where Y is not smaller than X. The taxi's flagged down fare is S, which covers W kilometers. W is not bigger than X, no need to say Y. The price after the first W kilometers is R per kilometer. If they share the fare on the pro rata basis, the fees that the 2 persons need to pay are A1 and A2 respectively. By using the second strategy, the fees that they need to pay are B1 and B2. In yesterday's example, we had B2 bigger than A2. Now our question is, under what conditions? B2 is not bigger than A2? Why not give a try, and we will come back soon. Let's calculate A2 and B2 separately. For A2, the first is the flagged down fare, S, plus the mileage that is not covered by the flagged down fare, Y minus W, multiplied by the price, R, and then multiplied by the ratio, Y over X plus Y. For B2, we calculate the cost of the first X kilometers in a similar way, and divide it by 2, plus the cost after X kilometers. Now we can discuss the conditions under which B2 is not bigger than A2. This comparison is still a little complicated for students from the 6th grade, and we need to use some tricks. First, we notice that there are some similar factors on both sides. Attention please. They are just similar, not identical. On the left side it is X minus W, whereas on the right side it is Y minus W. It would be nice to have the identical parts. How to make it? We may start with this term, R times Y minus X. We divide it into 2 identical parts. And then move one of the parts into the brackets to make up Y minus W. Then there's half R times Y minus X left. Now let's look at the coefficients of these 2 factors. On the left side it is 1/2, whereas on the right side it is Y over X plus Y. Still not the same. Again, let's find a way to obtain the same coefficients. The following is a very common trick used in fractional calculation. Y over X plus Y is equal to Y plus X over twice X plus Y minus X over twice X plus Y. The former term is in fact 1/2. So A2 also has the same part. Plus Y minus X over twice X plus Y, times S plus R times Y minus W. Now the first terms on both sides are exactly the same. So we just need to compare the second terms. They also have 2 identical factors. One is 1/2, and the other is Y minus X, which is also not a negative number. So we just need to compare R to S plus R times Y minus W over X plus Y. We first multiply X plus Y on both sides. And then move R times Y minus W to the left. And we get a comparison of R times X plus W and S. That is, when the value of R times X plus W is not bigger than the value of S, no matter what Y is, B2 will not be bigger than A2. We have to say that this part of the derivation is a little more complicated for most of the students from the 6th grade. However, the conclusion is not that difficult to understand. That is, if it is desired that, with the second strategy, the second person's share of the cost is not bigger than the cost on the pro rata basis, then the first person's share of the cost of the first part of the journey, which is S plus R times X minus W, then divided by 2, cannot be smaller than the second person's share on the pro rata basis in the situation that both strategies give the same result, and which is actually R times X. The two conclusions are actually equivalent to each other. We can verify this conclusion with a few examples. For example, we discussed yesterday, S equals 13, R equals 2, X equals 10, W equals 3, then R times X plus W equals 26, which is significantly bigger than S. To calculate B2, we also need Y equal to 15, although it has no effect on the comparison. Putting them all into the expression for B2, we can calculate B2 is equal to 23.5. And in the same way, putting all of them into the expression for A2 gives A2 equals 22.2. So B2 is indeed bigger than A2. What if we set S as 26, which is equal to R times X plus W? Then B2 is equal to 30. And A2 is also equal to 30. They are indeed equal. We continue to increase S to 36. B2 is equal to 35. And A2 is equal to 36. At this time, B2 is smaller than A2. Therefore, we have completely made clear the topic regarding when two persons share the fare. Under what conditions? Who will share more in the comparison between the two both reasonable sharing strategies? Then going back to yesterday's example, what about case of three persons sharing the fare? Let's continue the discussion tomorrow. Thank you for watching, and see you tomorrow.